Are you enjoying this baby math? In the very least, I hope you're appreciating it. It's easy, isn't it? It's fun, not that difficult. We're doing area and volume. We'll get to volume more toward the end. Right now, we're just really doing area. We've done parallelograms, such as rectangles and squares. We did trapezoids and triangles yesterday. Well, today we're going to do the area of circles, and I just want to remind you of a few key thoughts involving circles before we get into the problems themselves. And these two thoughts are simply this: that half of the distance across a circle it's a little one, I know. Actually, let me make it probably just a little bit bigger here to help. Not a lot bigger, but maybe a little bit. Half of the distance across a circle is r, or a radius. Okay, write that down. Half of the distance across a circle is r, or a radius. All of the distance across from one side of the circle to the other side of it is known as the diameter. Okay, the diameter. Write those two things down. Now, the second thing that I want you to write down, other than those collectively considered, is this formula. This is going to be key. The basic formula for finding the area just of a single triangle, only one, is A, standing for area, obviously, equals pi. Okay, and it's the two lines with a wavy line on top, and you know about pi, you learn about it in elementary school. Pi, which we're going to use as a figure 3.14. Now, technically, it's not that. It's an irrational number. It has no repetitive pattern, and the decimal never ends. Therefore, it's irrational. But we're going to use 3.14 as is commonly done in math, just for simplicity purposes. Okay, so A equals pi, or what will be 3.14 every time, times the radius, which is only half of the distance across. But this is important. That's not times 2, that's squared. Or the radius times itself times pi always gives you the area of that circle, no matter what that circle is, how large or how small. Okay? Now, there will be a lot of problems where you're given the radius. And so all you have to do to find the area is just plug in that number, square it, then multiply it times 3.14. Simple as can be. Don't forget units squared, though, whatever those units are. That's the way you treat units when you're figuring area of anything. However, there will be some problems in which you are given the diameter, and you have to divide that in half. Okay, diameter divided by 2 gives you the radius. Does that make sense? Because diameter is all the way across, but to have the radius, you only use a figure that's halfway across. So keep your eyes peeled for that. We will have some of those problems, including we will have one even in our examples today. Okay, we'll deal with this formula when we get to that point. We're not there yet. Number 1, find the area of a circle if you are told, you are given this information, that the radius of that circle is 3 kilometers. Okay? So the area of the circle is 3 kilometers. And so what do? Where do I start? First thing I do is write my formula. What is my formula for finding the area of a circle? It is A equals pi r squared. Okay, from that point, I'm just going to plug in here so I get used to knowing what the value is for pi. I say get used to knowing what it is, just remind myself of what it is, remind yourself of what it is. We know what it is. 3.14 times, what's my radius, guys? I have been told that my radius already is 3 kilometers. We'll drop the units for now. We'll put them back in when we're done. But don't forget that important 2 number. That is not times 2. It's not 3 times 2. It's 3 squared, which is 3 times 3, which of course is 9. If you haven't already, grab your calculators, and we're going to punch in information on each one of these. I'm letting you guys use your calculators on these. You don't have to work it all out by hand, okay? So I'm going to punch in, based on what I have on the board, 3.14 times 3 squared. Remember order of operations. Even though the multiplication comes first, I don't do multiplication first. I do the exponent first because it's the second order of business in order of operations, and multiplication is third. So what I'm going to do is multiply 3 times 3, okay? Or let me show you guys the other way of doing that. On my calculator, 3, and see this x, there you go, see that x2 button, or x to the second power? I can hit that and see it makes it 3 squared, which is what? 3 times 3, which is 9, okay? But 3 squared, all right, I'll do it that way to show you the difference here, times 3 let's just do it this way. 9, right? Answer, because it's trying to do funny math monkey business on me, and I don't like when my calculator does funny monkey math business. So 9 times 3.14 now equals 28.26. And what we're going to do for all of these, for our areas and our volumes, let's round it to the nearest tenth. So the first decimal place, the nearest tenth, unless we're otherwise instructed. So what would that number be? 28 points, would it be 2 or a 3? Do I go up or do I stay where I am? I go up, don't I? Because that's a 6. So 28.2, or I'm sorry, 0.3 is going to be the solution. 28.3. Now, what units? In what units do I put this? 28.3 kilometers. But what as far as kilometers? Kilometers squared, because I'm finding A, or area, and area of anything is measured in units squared, whether it's feet, inches, centimeters, kilometers, etc. Okay, number 2. Let's find the area of a circle if I'm told that the diameter is 5. Okay, let me first write what my formula for finding the area of a circle is. A equals pi, say it with me, A equals pi r squared. Okay, so I have to have a radius to square it. Do I have a radius that I'm given in that information? No. I have a diameter, which is different than a radius. A diameter is all the way across. And for my formula, I need a distance that's only halfway across the circle. So how do I figure a radius, or halfway across, from a diameter which is all the way across? All that I do, guys, is take that diameter and I divide it by 2. And this is so simple, even though it's not an even number, we can do this in our heads. What is 5 divided by 2? In other words, how many times does 2 go into 5 evenly? That would be twice, okay, and 2 times 2 is 4. And I have a leftover of 1. And I divided by 2, and so I have 2 as a whole number, and as a fraction, 1 in the numerator, and what's in the bottom number is my divisor, which would be 2. So 1/2, 2 and 1/2, or let's express that as a decimal. We're going to do in these, not do fractions. And so my radius, right up here, my radius, if I have a diameter of 5, and I just divide that by 2 to get my radius, then my radius is going to be 2.5. So A equals pi times r squared. The value of pi is Passamaquoddy? 3.14. That is correct. Very good. R. What's my radius? Not my diameter. What's my radius? Times 2.5, close parentheses, squared. Okay, remember, that's not 2.5 times 2, which would take us right back to square one and put us at 5. It's going to be a number a little different than what you might think, okay? We're going to have 2.5 times 2.5, and so instead of doing the squared this time, I'll just put it in my calculator that way. That's really easy. See, it's not 5. It's quite a bit larger than 5. It's 6.25. Now, I don't know if your calculator's this way, but I can just hit the answer button, and then it just leaves me that number right there. And then I'm going to multiply it times what we ascribe the value of pi to be, which is 3.14 approximately. And what's my answer going to be? To the nearest tenth, which is 1 decimal place, 19.6. Does that 2 make me go up or stay where I am? I stay where I am, don't I? At 6. So my answer is 19.6. The area of this circle is 19.6. So what do you think? 19.6 kins? No. What's our unit over here, guys? Meters. And area is always measured in units. What? Ken likes when I say it that way. Squared. 19.6 meters squared. Now, number 3 is a little bit different. We're not trying to find area only involving one circle, okay? Even though we want to find the area of a certain circle, we have to use the area of 2 circles to find that. And that's where the handy-dandy formula of area involving 2 circles comes into play. And that is A equals pi times, notice, big R, okay? And all that means is the larger of 2 circles that are involved. The radius of the larger of the 2 circles squared minus pi times little or lowercase r squared, so the radius of the smaller of the 2 circles that's being considered. And I hope it shows up clearly in what looks like a donut up here. Oh, I could use a donut right now. How about you guys? But I have a larger circle, okay, which is the whole thing, and then there's a smaller circle found within that bigger of the 2 circles. And in case the numbers don't show up clearly, the larger of the 2 circles has a radius of 6 meters, and the smaller of the 2 circles has a radius of 4 meters. So the larger has a radius of 6 meters, okay, and the smaller has a radius of 4 meters. To figure out what the area of the colored region, only a part of these 2 circles is, and especially this one main big one right here, what I'm going to do is employ this formula, and I'm going to write it to gain familiarity with it. A equals pi big R. That still means radius, but I'm just writing it that way because it reminds me that the larger of the 2 circles, its radius comes first. A equals pi big R squared minus pi lowercase r squared. Okay, so as I rewrite this formula, A equals in 4 pi, I'm going to put 3.14. Okay, so I can again just really get that drilled in my mind what the value of pi mathematically is, times big R. Which one is the larger of those 2 radiuses? Which one is the larger? It's the 6m1, and so I'm going to plug in 6. Don't forget your squared, and remember that's not times 2, but 6 squared minus pi, which we're using 3.14. And what's the radius now? Times the radius of what's the smaller of the 2 radiuses? It would be 4 in parentheses. But don't forget, we're squaring that 4. Okay, now what we're going to do is order of operations. All right, order of operations. Even though there's multiplication that comes first in terms of from left to right, we don't do things in that order. And the reason we don't do things in that order is because we have an exponent. And that's second in the order of operations, and so that's going to come first. So, I'm going to do 6 squared in my head, and I want you to do it too. What's 6 times 6? That's 36. See, we don't even have to punch that one in. 6 times 6. We know it's already 36. Times pi, 3.14, which is 113.04. Guys, rounded to the nearest decimal, what is the first decimal place, the 10th spot? What is 113.04? That is simply 113. We don't put 0.0 because that's meaningless. Let's go ahead and write minus so we don't have to worry about recalling that. Let's take care of that business first. Okay, now we have pi, or 3.14, times 4 squared. Let's do our 4 squared first in our heads. What's 4 times 4? That's 16. We don't have to put that in our calculator. 16 times 3.14 equals 50.24. Okay? How do I round that to the nearest first, that is, decimal place? Do I go up or down? Or do I go up, or do I stay where I am with that 4? I stay where I am in relation to that 2. And so it's 50.2. 50.2. Easy peasy lemon squeezy from here, guys and gals. All I do is just subtract now. Simplest of all math. 113 minus 50.2 equals 62.8. So my area is 62.8, and I need to go back and look at my units. What are they? Meters. And we know by this point that those meters, like any unit in calculating area, need to be squared. And that tells me, guys, the area of just the shaded region. That's kind of cool, isn't it? And so you can use the 2 circles to help you to determine that. Now this one I think is really fun. You might disagree with me, but zip it if so. Number 4, the area, find the area of this figure. It looks kind of like a bullet, doesn't it? How do I find the area of this oversized, what's going to appear to be, because it's meters, a war bullet, a ballistic missile head? How do I find the area of this? Well, this is really cool, because if you'll notice, there's like 2 shapes here in one, and the one's pretty obvious from here to here. I'm going to go ahead and draw a line, okay? And I don't mind if you guys do that on your homework, maybe as well on your test. Okay, I'm going to draw a line here, and what's the shape of that first one? I probably should have made it a little longer, but I know it kind of looks like a square, but really that's not a square. It's not drawn to scale, okay? You can tell by the difference in the width and the length that's actually a rectangle, the first one. And the second one is like a wannabe circle. The only problem is it's missing half of it. That's only half a circle. Now that's important information. How do I figure the area of this shape? The way that I do that is just treat this like it is. First of all, it is a rectangle. Even though it kind of looks like a square, it's a rectangle. And my formula for a rectangle is either length times width, that's okay, or like we did here a couple of days ago, B times H, or base times height. Same thing as length times width, okay? Don't let that confuse you. But what is the length and what is the width, or the base and the height? Well, the base, or where it rests, is 6.5, okay? And the height is what? 4.4. Okay. So what's the area? What is the area of that rectangle? Well, since I'm letting you guys do it, I don't mind if I do myself. Just punch it into my calculator. It is 6.5 times 4.4, which is 28.6. Okay? So I'm going to write down 28.6, and that's going to be what units? Meters. That's right. Squared. Okay. Now, that was easy, but what do I do with this mess when I only have half of a triangle? What do I do when I only have half, or I'm sorry, that was yesterday, half of a circle? I'm trying to spit out. If I only have half of a circle, what do I do with that information? Well, let's remember right over here. What's the area of a single circle? A equals pi times r squared. Now that's for a whole circle. If I wanted to find out what the area of half of the circle is, what do you think the formula would be? It is exactly the same thing, except it's times 1/2. Okay? Or if you prefer, you could put all of this divided by 2. That means exactly the same thing mathematically. But here's an easy way of doing it. The area of half of a circle is 1/2. Makes sense, doesn't it? times pi times r squared. What do I know the radius of this circle is? Look, the distance from one side of the circle all the way to the other side, I know from this shape to be 4.4 meters. Now that's the distance all the way across. Listen up. I'm not trying to find the distance all the way across. I'm only trying to find the distance halfway across, which is my radius, which is key for my formula. And so, for my radius, I'm going to put here, this is my diameter, okay, 4.4. How do I find radius from diameter? I simply divide 4.4 by 2. Cut it in half. 4.4 divided by 2 is, 4 divided by 2 is 2. Decimal point, 4 divided by 2 is, guess what? 2 again. Funny how math works, isn't it? 2.2. And so my area equals 1/2 times we're not playing golf, guys, we're doing math. Times pi, okay, and I'm going to go ahead and actually plug in. If you already wrote it down, don't worry about it, you don't have to erase it if you understand. Pi is 3.14. But 1/2 times 3.14 times, what's my radius? Not my diameter, 4.4, but my radius, 2.2 squared. Okay, so what is all of that mess multiplied together? Well, let's do that on our handy dandy man-made calculators. Okay, we're going to start with 2.2 squared, even though it comes last in the arrangement. It's all the way to the right because of order of operations. So I'm going to punch in, first of all, 2.2 times itself, which is 2.2, okay, and that equals 4.84. All right, and then we can do all this just one after another, left to right, right to left. Technically, we're supposed to go left to right, but since it's all multiplication, it makes no difference in what order you do it. They're all going to be multiplied to each other in the end. So 2.2 times 2.2 is 4.84. We're going to multiply that by 3.14, which is pi, okay, by 3.14. which is 15.1976, okay? And then, look at the board, we're going to multiply that by all that's left, which is 1/2. In decimal form, that's going to be times 0.5. And so what do I have? 7.5988, okay? How do I round that to the first decimal spot? I have a 5, do I keep that 5 or do I go up? What's the 9 tell me? I go up. And so my answer is 7.6. My area is 7.6. What's my units? Same as before, meters and squared, because we're finding area. So look, I'm still not done though. What I've done is I found the area of this rectangle is 28.6. And I found that the area of this half circle is 7.6. Okay, so what is 28.6 plus the area of the whole shape? Add it all together now. 28.6 plus 7.6. All right, 0.6 plus 0.6 is 1.2. I'm going to carry my 1, and I have 8 plus 7, which is 15, plus 1 is 16. Okay, I'm going to carry my 1 over here. 2 plus 1 is what? 36.2. 36.2. And that remains, guys, since it's area, it remains in meters squared. Alright, and that is our math lesson for the day, boys and gals. That is our math lesson, our final one for the week. We're into the weekend, math-wise. And so I will not see you in math class again until next Monday. Sound all right? Deal. Have a good weekend, guys.